Hello everyone. So continues on the solving part of the trig equations. Now we have this 7.6 solving quadratic trig equations. So in our previous video, you have seen examples on solving linear trig equations. So now we have this solving quadratic trig equation. So obviously in most of our example, you will see that our equation will have the exponents of 2 because when the highest power is in the equation is in power 2, that means this is the quadratic. Okay, so solving again for x or for theta, for any kind of an angle, when the angle is in between 0 and 360, then you have to make sure that the angle that you're solving for, it will satisfy with the given domain. All right. So again, just like solving the linear, we have to isolate the variable terms by itself. So in example number 1a, the question is already, the sine square x is already by itself. So all we have to do is to make sure that we get rid of the power 2. So basically you're going to square root both sides. When you square root both sides, you're getting a plus and a minus of root 2. Okay? And again, to solve for the angle, we always want to look at the related acute angle beta. Okay? Because this is a plus and a minus, and I want to quickly remind everyone that because of the cast roots, so when the ratio of the sine length of the sine is a positive, you get two quadrants, quadrant 1 and quadrant 2. But because of the negative, so that means you will also have another possible answer in quadrant 3 and quadrant 4 for the negative root 2. All right? So when you punch it in from your calculator, you will realize that so when you're taking the inverse of the root 2, okay, you don't have to put in the plus and the minus because the related acute angle is always positive. Then you will realize that there's no solutions for that. Okay? Why is no solutions? Well, think about that. Because the sine of an angle, you're taking the opposite, okay, over the hypotenuse. And because the hypotenuse length is always the biggest number, so when you're taking a smaller number divided by a bigger number, your answer is going to be a fractions, okay? And if you take a look at the root 2, then you will see that a root 2 will not be giving you a decimal, okay? That's less than 1. So that is the reason why sometimes you will have no solutions, okay? So let's take a look at when there's no solution, then there's nothing we can do about it. So this just, the x has no solutions, okay? So continues on the example 1b, where you have a 3 sine square x equal to 2. So again, we're going to isolate the sine square x. Okay, so step 1, you're going to get rid of the 3, so it becomes a 2 over 3. Okay, and then take a square root on both sides, so you ended up with the sine x is going to be equal to a plus and a minus, don't forget that, of a 2 over 3. Okay, so again, you will have solutions in both quadrant 1 and quadrant 2 for the positive, and you also have a solution in quadrant 3 and quadrant 4 for the negative. Okay, because of plus and a minus. So usually when it comes to the quadratic trig equation, you will have multiple answer. Okay, now so first we need to find out whether the related acute angle Okay, so think about if the principal angle will happens in all four quadrants, then it's important to find out what your related acute angle is by taking the inverse of the sine and by taking the root of a 2 over 3. Okay, and that will be approximately, that will give you approximately, this is not going to be a special angle. So the only thing that you can do is by using the radian mode and get yourself this radian measures 0.9553. Okay, remember we like to make sure that when you round it to 4 decimal places, then the answer will be more accurate for the principal angles. So the principal angles in quadrant 1, and since the x is going to be, the principal angle is going to be equal to the related acute angle, so you have the same answer. Okay, and in quadrant 2, since the principal angle is equal to pi minus the related acute angle, so you're taking the pi minus that related acute angle, you're going to get 2.1663 rad. Okay, approximately. And then continue. So this too will give you the positive ratio. Okay, so in quadrant 3, the principal angle is equal to pi plus the related acute angle, so you will be getting approximately 4.0969 rad. And then in quadrant 4, the principal angle x is equal to 2 pi minus the related acute angle, so you'll be getting approximately 5.3279 rad. Okay, and these two angles, they are the negative ratio for in quadrant 3 and quadrant 4 for the sine that is a negative. Okay, so this is going to be the 4 solutions that you have for this particular questions. And now let's continue working on the example C, where you have a tangent square x minus a 4 tangents of x minus 5 equal to 0. Okay, because you have a tangent here, tangent square x and a tangent x there, so you can look at if you can use the one of the strategies that I showed you before. If I let a single letter be the tangents of x, okay, so you can replace this question as a squared minus a 4a minus the 5 that's equal to 0. Okay, if you, that makes the question a lot easier in your eyes, do that. But if you can work with the tangents of x, go ahead. But this just like a simple trinomial. You are getting a simple trinomial. It's just that now everything is in the trigonometry form. Okay, that's all. Okay, so when you factor this, a simple trinomial, you will see that you are getting a minus the 5 and a plus the 1. Okay, minus 5, 1 give you minus 5. Positive a minus 5a, you get a minus 4a. So this is a simple trinomial. So a minus 5 is equal to 0, so a must be equal to 5, or a must be equal to negative 1. But because a, in fact, is equal to tangents of x, so you can replace this back as a tangents of x that is equal to 5. And then you have a tangents of x that's equal to negative 1. So you can, well, for the tangents of an angle that's equal to a positive, so you know that this is going to be according to the Cash rule. Tangent is positive in quadrants 1 and quadrant 3. Quadrant 1, quadrant 3. But tangent of an angle that's equal to a negative, and it's going to happen in quadrant 2 and quadrant 4. Okay, so from there, you know that you will have 4 different solutions for that. Okay, now solving for the tangents of x that's equal to 5, then again, I need to find the related acute angle beta by taking the inverse of the tangents, set it for 5. So that is going to be equal to approximately 1.3734 rad. Okay, so therefore in quadrant 1, x is going to be equal to the related acute angle, so is 1.3734 rad. But in quadrant 3, I have x, it's the principal angle is equal to a pi plus the related acute angle. So that will give you approximately, this is going to be a 4.5150 rad. Okay? Now, for the tangents of x that is equal to -1, okay, and we're going to calculate first, we're going to calculate the related acute angles again by taking the inverse of the tangents for 1 and not -1, okay? And you know that when tangent is equal to 1, that means this angle is going to be a special angle is a pi over 4, the 45. Okay, opposite one over adjacent one, 1 root 2. So you know that this is going to be the exact, this is one of the special angles. So when this is a special angle, I expect the answer has to be in exact form. When the related acute angle is not one of the special angle, then yeah, you're allowed or you must use the approximate form, like and round it to 4 decimal places with the rad it comes after. But if this one is one of the special one, then you must state it in the exact form and not the approximate form. Okay. So now in quadrant 2, because this one only happens in quadrant 2 and quadrant 4. X is equal to pi minus the beta, the related acute angle. So you have a pi minus the pi over 4. So that will give you 4 pi minus pi, so it's 3 pi over 4. Okay, in quadrant 2. But in quadrant 4, where the principal angle x is equal to 2 pi minus the related acute angle, so that basically is going to be equal to 2 pi minus a pi over 4, common denominator, so you have a 8 pi minus a pi, so it's a 7 pi over 4. Okay, so here is one of the answer here in quadrant 2. Here is the answer for in quadrant 4. And over here, I have an answer in approximate form for quadrant 1. And here I have an answer in quadrant 3 in approximate form. Okay? So for example number C, you have 4 answer or 4 solutions again, just like the previous one. Okay? So D, well, if regardless whether this is a reciprocals or not, but again, this one looks like is a complex trinomial. Okay, so again, if I'm going to let A be the cosecant x, okay, that means I will have a 3a squared minus a 2a minus 1. That's equal to 0. Okay? And when you factor this complex trinomial, okay, you can use guess and check or decompositions method, you will see that you will have a 3a plus the 1 and the a minus 1. So again, you're going to double check the smiling face. Plus 1 times negative 1 give you negative 1. A minus 3a plus a will give you a minus 2a. So this one works. Okay? So now you have either 3a plus 1 that's equal to 0, or you have a minus 1 equal to 0. So solving for the a, you know that this one a is equal to negative 1 over 3, and this one here a is equal to positive 1. Okay? But a, we know that a in fact is equal to cosecant x. So I'm going to replace the a with the cosecant x. That is equal to negative 1 over 3. But cosecant x, we cannot do a cosecant x from our calculator, right? So it's important that we turn any reciprocal back to the primary. So cosecant x is the same as the reciprocal is a sine x. When you flip 1 divided by that, well, the negative won't change. But now you have a negative 3 over 1. Okay? So a sine x that is a negative, that means I know according to the cast, I have in quadrant 3 and quadrant 4 that is negative. Okay? So according to the cast rules. So now I need to, okay, let me just divide this again, because here, the other possible solutions for the a is a equal to 1. So again, I'm going to take the cosecant x, replace the a with the cosecant x, that is equal to 1. And because this is positive, right? So I know that I will have to turn this into a primary. So again, this is going to be a sine x, but I'm taking 1 divided by 1, which is still giving me 1. Okay? So positive, I have in quadrant 1 and quadrant 2 for sine. Okay? So now, to finish it off, all I need to do is to find the related acute angle beta by taking the inverse of the sine with the 3 in it. Okay? And so again, because this is not a decimal, opposite over the hypotenuse, I'm supposed to get some decimal. So this will be similar to our example number A, okay? When you have the inverse of the sine ratio that is going to be greater than 1, then that means there's no solution. So same thing over here. Because the when you punch it in, you will find out, the calculator will tell you, okay, there's no solutions for that, because you will not have a ratio of 2 sine length that will give you a 3, okay, for sine. Because a sine, when you take the opposite over the hypotenuse, you're supposed to get an answer that's less than 1, okay? When you take a small number divided by a bigger number, you always get less than 1, but you cannot get 3. So this part has no solutions. But for this part here, this is going to be a special angle. A sine of an angle that's equal to 1, then related acute angle or the principal angle has to be pi over 2. Okay? So this one really, you don't have 2 solutions, because this is a special angle that lands on the y-axis. Sine of some angle that's equal to 1, then x has to be equal to pi over 2. Okay? So this will be the only solutions for the part D.